You're now staring face first into the abyss of a black hole, and the abyss is staring back, its gravity warping the fabric of space and time around you. This is the point where your imagination should be running wild, but your brain is about to get a serious workout, trying to comprehend the physics of this cosmic nightmare. As you fall, the gravity of the black hole starts to play a game of cosmic tug-of-war with your body. The force on your feet is becoming incredibly stronger than the force on your head, and this difference in gravitational force, known as tidal force, is stretching you out like putty in a theoretical physicist's hands. The closer you get to the singularity, the more extreme this stretching becomes, until you're nothing more than a long, thin, atomic noodle being pulled toward the point of no return. But here's the thing. This isn't just some theoretical concept. It's a real phenomenon that has been predicted by the laws of general relativity. And the really cool thing about it, if you can call it that, is that it's not just your body that gets stretched, it's also time itself. According to Einstein's theory, time dilation occurs when you're in a strong gravitational field, which means that time passes differently for you relative to someone who's observing from a safe distance. Now, imagine being that observer, watching your friend fall into a black hole. From your perspective, time seems to slow down for them as they approach the event horizon. They appear to slow down, and then they just seem to freeze, suspended in time like a statue. But for your friend, time is passing normally, until the point where the gravity becomes so strong that it overpowers all other forces, and they get spaghettified. The really interesting thing about black holes is that they're not just cosmic monsters, they're also cosmic puzzles. Scientists love studying them because they offer a unique opportunity to test the laws of physics under extreme conditions. By studying how matter behaves near black holes, scientists can gain insights into the fundamental nature of space and time, and maybe even uncover some of the secrets of the universe. But let's get back to you, falling into the black hole. As you approach the singularity, the gravity becomes so strong that it starts to warp the fabric of space and time around you. The laws of physics as we know them start to break down, and the concept of space and time becomes increasingly distorted. It's a bit like being in a funhouse, where the rules of reality no longer apply, and the distorted mirrors reflect not just your image, but the very fabric of space-time itself. The experience of falling into a black hole is often described as a journey through a cosmic wormhole, where the gravity is so strong that it creates a tunnel or tube through space-time. As you travel through this tunnel, the gravity becomes increasingly intense, and the distortion of space and time becomes more and more extreme. It's a bit like being on a cosmic roller coaster, where the laws of physics are the tracks, and gravity is the force that's pulling you through the loops and corkscrews of space-time. But what's really interesting about this journey is that it's not just a one-way trip. The gravity of the black hole is so strong that it warps the fabric of space-time, creating a kind of cosmic echo chamber. As you fall toward the singularity, your image is reflected back to the observer, creating a kind of cosmic mirror effect. It's a bit like being in a hall of mirrors, where your image is reflected back to you from multiple angles, each one distorted in a different way. As you continue to fall, the gravity becomes stronger and stronger, until you reach the point where the laws of physics as we know them start to break down. This is the point of no return, where the gravity is so strong that nothing, not even light, can escape. It's a bit like being in a cosmic black box, where the rules of reality no longer apply, and the only thing that's left is the gravity, pulling you toward the singularity. But even in this extreme environment, there's still a kind of beauty to the physics. The gravity of the black hole is so strong that it creates a kind of cosmic symmetry, where the laws of physics are reflected back to us in a distorted way. It's a bit like being in a cosmic funhouse, where the rules of reality are reflected back to us in a distorted mirror, and the gravity is the force that's pulling us through the loops and corkscrews of space-time. As you reach the singularity, the gravity becomes infinite, and the laws of physics as we know them start to break down. This is the point where the concept of space and time becomes increasingly distorted, and the rules of reality no longer apply. It's a bit like being in a cosmic singularity, where the gravity is so strong that it creates a kind of cosmic point of no return, and the only thing that's left is the gravity, pulling you toward the center of the black hole. But even in this extreme environment, there's still a kind of wonder to the physics. The gravity of the black hole is so strong that it creates a kind of cosmic wonderland, where the laws of physics are reflected back to us in a distorted way. It's a bit like being in a cosmic dream world, where the rules of reality are reflected back to us in a distorted mirror, and the gravity is the force that's pulling us through the loops and corkscrews of space-time. As you disappear into the singularity, the observer watching from a safe distance sees you freeze in time, suspended in the event horizon like a cosmic statue. But for you, time has come to an end, and the laws of physics as we know them have broken down. It's a bit like being in a cosmic time machine, where the gravity is so strong that it creates a kind of cosmic time dilation, and the only thing that's left is the gravity, pulling you toward the center of the black hole. But what's really interesting about this cosmic time machine is that it's not just a one-way trip. The gravity of the black hole is so strong that it warps the fabric of space-time, creating a kind of cosmic echo chamber. As you fall toward the singularity, your image is reflected back to the observer, creating a kind of cosmic mirror effect. It's a bit like being in a hall of mirrors, where your image is reflected back to you from multiple angles, each one distorted in a different way. As the observer watches, your image starts to fade away, lost in the vast expanse of space-time. But the memory of your journey lives on, a reminder of the cosmic wonders that await us in the vast expanse of the universe. And who knows, maybe one day we'll uncover the secrets of the black hole, and the mysteries of the cosmos will be revealed to us in all their glory. But until then, the journey into the black hole remains a cosmic puzzle, waiting to be solved by brave astronauts and curious scientists. The cosmic pasta maker, as we've come to call it, is a reminder of the awe-inspiring power of gravity and the mysteries that await us in the you're now face to face with the ultimate cosmic terror, the point of no return, where gravity's grip is so strong, not even light can escape. As you fall into the black hole, you start to feel a strange, unsettling sensation. It's as if gravity is playing favorites, pulling on your feet with a force that's exponentially stronger than the pull on your head. This is the beginning of the spaghettification process, where the difference in gravitational force between your feet and your head starts to stretch you out like a piece of cosmic pasta. Imagine being on a stretching rack, with an invisible force pulling on your toes and your head, stretching you out to impossible lengths. The closer you get to the singularity, the more extreme this stretching becomes, until you're nothing more than a long, thin strand of atoms being pulled towards the point of infinite density. This is what physicists call the tidal force, and it's the key to understanding the terrifying phenomenon of spaghettification. As you continue to fall, the gravity's grip on your body becomes more and more intense. The stretching force is so strong that it starts to overcome the molecular bonds that hold your body together. Your muscles, your bones, your very cells, everything is being pulled apart by the relentless force of gravity. It's a truly horrifying prospect, and one that challenges our understanding of the fundamental laws of physics. But what's even more fascinating is that this process is not just a product of the black hole's gravity. It's also a result of the way that space-time is warped and distorted by the singularity. As you approach the point of no return, time itself starts to slow down relative to the outside universe. It's a phenomenon known as gravitational time dilation, and it means that the closer you get to the singularity, the slower time passes for you, relative to the rest of the universe. So, as you're being stretched out like a piece of cosmic spaghetti, time is also slowing down for you, relative to the outside universe. It's a mind-bending concept that challenges our understanding of space and time, and raises fundamental questions about the nature of reality itself. And yet, despite the terror of spaghettification, scientists are drawn to the study of black holes like moths to a flame. It's a puzzle that's both fascinating and terrifying, and one that holds the key to unlocking the secrets of the universe. As you continue to fall into the black hole, the gravity's grip on your body becomes more and more intense. The stretching force is so strong that it starts to overcome the molecular bonds that hold your body together. You're being pulled apart at the molecular level, your atoms are being rearranged, and your very sense of self is being torn apart by the relentless force of gravity. It's a truly terrifying prospect, and one that raises fundamental questions about the nature of consciousness and the human experience. But what if you could survive the fall into the black hole? What if you could somehow withstand the intense gravity and make it to the other side? It's a question that has puzzled scientists and science fiction writers for decades, and one that we'll explore in more detail as we continue our journey into the heart of the black hole. For now, let's just say that the prospect of surviving spaghettification is slim to none, and that the laws of physics as we know them are about to get a whole lot weirder. As you continue to fall into the black hole, you start to experience some really weird effects. Time, which used to be a steady beat, begins to slow down around you. This is called gravitational time dilation, and it's not just a theory, it's been proven by scientists. From the outside, it looks like time is passing normally, but for you, it's a different story. You see, time is relative, and when you're in a strong gravitational field like the one near a black hole, time starts to move at a different pace. Imagine you have a twin brother, and you both have identical clocks. You stay on Earth, while your twin brother goes on a journey to a black hole. As he approaches the event horizon, time starts to slow down for him relative to you. For every year that passes for you on Earth, only a few minutes might pass for your twin brother near the black hole. It's a pretty mind-bending concept, and it's not just limited to black holes. Any object with a strong gravitational field can cause time dilation. But here's the thing. From your perspective, as the astronaut falling into the black hole, time feels normal. You don't feel like time is slowing down or speeding up, it just feels like time. It's only when you compare your experience to someone outside the black hole that the differences become apparent. And that's what makes this phenomenon so fascinating. It challenges our classical notions of time and space. As you fall deeper into the black hole, the laws of physics start to break down. Space and time become distorted, and the rules that govern our everyday reality no longer apply. It's like being in a cosmic funhouse, where the laws of gravity and motion are more like suggestions than strict rules. The gravity of the black hole is so strong that it warps the fabric of space-time, creating a region where the usual rules of physics don't apply. The experience is almost surreal. You're not just falling through space, you're falling through space-time itself. The gravity of the black hole is pulling you apart, stretching you in the direction of the fall, while compressing you in the other directions. It's a truly bizarre sensation, and one that's impossible to imagine without actually experiencing it. So, what do you think? Are you ready to take the plunge and experience the ultimate cosmic ride? Or would you rather stick to more mundane adventures like Sky?